Okay. All right, I will keep this short so that we can get on to the important business of the evening. However, I wanted to give you just a little vision of where we go from here. What you've seen so far is all going to get deployed beginning July the 1st, commercially. For Pioneer members who sign up to our program, you'll start to receive your units in March and April, depending on when you signed up. So what comes next? Well, I'd like to talk a little bit about some of our future vision about AR and voice assistants. So I'm having... Okay, so we've heard about a lot of these things today already. You know, the challenge of converting content to some new AR format, the challenge of fragility, the challenge of wearing protective equipment with these devices, and of course we've heard a lot about the challenge of not being hands-free. All of these challenges, I think by now you can understand that we have solved with the HMT-1. And so where that fits in is when we look at these use cases that we've explored today, technical field documentation, or Document Navigator is our solution to that. Data entry forms and reports, our solution that you saw from Interwear in the category of forms and workflow. Visual work instructions, we've seen that both from Interwear and at the PTC demo table if you've seen that AR demo. Remote Mentor, we saw that from LibreStream and from Hewlett-Packard Enterprise. And of course we have some other partners here like Pristine and Preologic and Ubimax who are showing that too. And IoT data visualization, which we saw from PTC and OSI Soft with the help of National Instruments. And of course, there are many other companies that fit into these categories too in the ecosystem at large. And so what we've seen is that the legacy of these types of work that field workers have to do has been paper and then handheld, such as the ones that David Krebs talked about, laser barcode scanning devices, and then starting in a few years ago, tablets. And it took a long time for tablets to make it from consumer to industrial enterprise because a lot of these problems had to be solved. Ruggedization, battery life, security, fragility, outdoor viewability. And so that indeed took about 6 or 7 years. It was really, I think, about 2014, maybe late 2013, that we saw the first large industrial enterprise deploy 1,000 tablets. Now, I don't think we've really yet seen the first large industrial enterprise deploy 1,000 wearables. I've heard of a couple of 500-unit deployments, so we're not far off. But it took 7 years for tablets. And we've seen folks with non-industrial wearables do a lot of pilots and demos and some small deployments on AR. And of course, we would stake a claim to perhaps being the industrial AR future. But we think it's going to take a while. It's going to take another 7 years, perhaps, maybe a little less, to cross the chasm to industrial immersive AR. What we've shown you today is not really immersive. It's not HoloLens. It's not Magic Leap. It's not stereo. It's not floating in tangible 3D space. It's what we like to call assisted reality. We think that's more useful, certainly in the short term, and more ready for deployment. But it's not that we don't believe in the future of immersive AR. We just think that, particularly in industrial heavy industry, it will take a little longer. Probably see it in consumer first. So this is what we call the chasm. And the chasm is populated by these 4 barriers that I've discussed. And the HMT-1 starts to get you across that chasm by solving those 4 barriers. But what comes on the other side? Well, I'd like to give you our vision of what that looks like. So this is a type of AR user interface that is entirely capable of being implemented on the HMT-1 and is fairly easy to see where this goes as you get more immersive. What you see here is something very similar to the Yelp app. If you've ever seen the Yelp app, then there's a feature called Monocle. And Monocle lets you hold your phone up to the world. I've got a phone, here we go. And look at restaurants that are in each direction. It just uses the compass and your GPS, and it puts little cards in your viewfinder, and I'll say, oh, over there, there's a restaurant, and it's got 4 stars, and if I tap on that little card, I'll go straight to Yelp's reviews, and I'll see all the information about that restaurant. Well, think about voice enabling that, and this is what you get. You get the power of say what you see combined with simple AR that we know works because Yelp has deployed it for years, but in an industrial context. So what we see here is a industrial plant, and we see various items in different directions that we can look at. The little circles at the bottom indicate there's content in that direction. The nearest ones are shown. They correspond to assets in the environment. Right? So we have a notification, a valve. We have work instructions. We have other dashboards. If I scroll along a little bit, we see that if I say work instructions 1, I'm going to go to some work instructions for that particular valve, AIS5. If I say open dashboard 2, I'm going to see an IoT dashboard that relates to that compressor. If I say remote mentor 2, I'm going to talk to an expert that knows about that compressor who's available right now. It's say what you see combined with simple AR. And it's contextual. So if I just animate these images, you see what it would look like as you move around. Okay, you've seen this before if you've ever used Yelp. You've just seen it for consumers. So let's say I want to open the dashboard for compressor 10.57. It might look like this. It might show me a composite dashboard that has 2 IoT data readings for that compressor, 2 remote experts, one of whom is available, Andrew Williams, who I could call right now, who knows about it, and the control circuit from a document navigator in one composite dashboard that I can get to in one voice command. I may go back and I may now say something else. Maybe I'm interested in the compressor, and now I can go deeper into the IoT data feed. And I can actually see 8 things because we have a wide VGA screen, which means that you can see enough data on there to actually do the job that you have to. And perhaps some of these I can double click on. I could call out their names and go down a level and see another 8 things. Have double height widgets, double width widgets. I'll go back and I can see now that I could say remote mentor 2 and look at the experts available for the compressor, and here we are, and we're now in a live video call with that person. And I don't lose the context. I can always say navigate back, and I go right back. Here's another type of app. This would be a safety procedure triggered by one of those cards. Right? Something very similar to what Interware showed us today, but triggered by an AR view rather than the view we showed you. With your voice, you can easily complete the safety checklist for this item and file it, and you've got compliance immediately, and you've got data about that. And we go and navigate back, and we go back here. And then finally, if I want to open the work instructions for valve AIS5, I would say work instructions 1, and now I'm seeing simple work instructions. Doesn't have to be 3D. It could be very sophisticated like what PTC showed us, or it could be something just snipped out of the PDF manual. It's still useful if you can get to it immediately, if you can get to it in context. In order to accomplish this, you have to do a few things. You have to solve the single sign-on security for all these different apps, because they're not all one app. There's multiple back-end sources of data. It might be SAP Work Manager. It might be the PTC ThingWorks. It might be some other platform. It might be something in Oracle. And so we need a single sign-on. We need to sign into our device, ideally with our voice, because dictating passwords works, but it's a little painful. So what we're going to implement is voice biometric single sign-on. You will enroll a passphrase with your voice, and probably a second factor, a PIN number or a QR code on the back of your ID badge, and you'll say your passphrase, and then you're signed into the device and signed into our cloud, and on the back end using well-known internet standards like OAuth or SAML, you can now be signed into all of your apps. And so the first part of solving this is to have single sign-on so that you don't have to say open work instruction 1 and now I have to enter a password and a user ID, because that would not be very nice. So that's where we think we're going, even in the HMT-1, not at launch, but over time, with partners who are interested in simplifying the interface to the Internet of Things and bringing in pragmatic, simple, deployable, immediate AR that works here and now. We'd like to build this. This can be done quickly from a technology perspective. There's no rocket science here, built on what you've already seen us show today live. Right? It's a small step from what you've seen today to this. Okay, so the next direction I'd like to talk to you about is going beyond command and control voice. So what you've seen is at any given time, you can say a handful of things. You can say navigate back. You can say select item 1. You can say show pressure. The system is only listening for 6 to 10 things at once, And that's why it works in high noise. That's why with these two-word commands, with the noise cancellation we have, the microphone tuning we've done, the multiple microphones, you can get it to work in between 90 and 100 decibels of noise. When we ship finally on June the 30th, I think we'll be very close to making this work in 100 decibels of noise. Right now, what you see today at this event is roughly 90, 92 decibels of noise. It's working fairly well, but we have a little more work to do. But command and control is only part of the story. How do we get to natural language? Well, there's a trade-off with noise. What we want to be able to do is speak to our speech-centric system in the same way that you are getting used to speaking to other virtual assistants, but have our assistants be specialists in the industry that you're in. So I can talk to Alexa or Siri, and I'm sure I can find a great restaurant in San Carlos. I'm sure I can add something to my calendar, perhaps, and maybe I can call somebody from my phone book. But I can't ask it about the maintenance record for compressor 3. And I can't tell it to tell me what the gasket part number is for one of those pumps in the brewery that we need to replace. But we'd like to be able to do that. We'd like to be able to say, you know, and I've named it Parkinson in honor of Chris, but we may or may not stick with that. But we may say, Parkinson, what type is this pump? And what's its vibration? Has its vibration been getting worse? And we'll know because we're standing in front of it. We know where we are. We've geotagged it. And we know about pumps because we've seen lots of documents in Document Navigator that talk about pumps. And we should be able to launch a query to multiple back-end data sources and get a sensible answer in context. Alex, you're closest to this particular pump, and it's vibrating at 600 hertz, and it's trending up. And so that's an actionable piece of information. The next question I might ask is, when was this pump last serviced? Who was the technician who last serviced this pump? Can I speak to Joe right now? Hey, Joe. Did you see anything on the last service? This pump seems to be trending out of where we expect for the service interval right now, and you could be in a video call with Joe assisting you on why that is. If you could talk to it in natural language, that's the next step. So that's where we want to go. It's not done today, but over the next couple of years, RealWear will be innovating in this area. I want to just give you one little insight about the trade-offs that need to be solved to make this work. On the left, you see Siri. It's a pretty wide vocabulary in horizontal domains that apply to consumers, but it doesn't work very well in noise. If you've ever tried it, I mean, if you try, any of you right now in this noise, you probably won't get a great result from Siri. On the other side, on the right-hand side, you have WearHF, invented by Dr. Chris Parkinson. Works amazingly in noise. It's very intuitive to drive a limited set of things, and we can make it rather easy for applications to take advantage of that, but it's limited vocabulary. That's the trade-off. It's a triangle. You can have wide vocabulary, noise robust, or natural language, right? And at this point in time, you can pick two of the three. Good, fast, or cheap. You can't have them all, right? You can pick two of the three. Well, there is a middle ground. The middle ground is a vertical assistant. Maybe it doesn't have as many words as I can understand as Alexa, but maybe it knows the critical 500 to 1,000 words about this brewery. And perhaps it doesn't work in 100 dBs, but it'll work in 90. And over time, we get it to 95 and then 98. The key to that is machine learning. The key to that is to train these assistants on the contextual information that is relevant to the industry I'm in, where I'm an airplane mechanic servicing a jet engine, whether I'm a brewing manager or a brewing technician, whether I'm working in the oil and gas industry, whether I'm in any given industry that we can talk about, construction, logistics. There's a vocabulary that's important to that industry. It might even be the one that's important to that customer, or maybe it's just for that industry. Well, Document Navigator is a little bit of a Trojan horse, let me tell you, because when we attach barcodes or other location enablers on information, and we have our customers tie those things to PDFs, legacy documents which are full of words, what we are doing is we're getting the context of what words are important in that context to those users. We're building a heat map of the important words for that customer and that industry. Imagine that I have 100 technicians in an oil refinery, and they're all using Document Navigator, and they use it every single day. It's part of their normal operations. 3 months later, I have a very rich source of data about what the important words are in that oil refinery and what locations in that oil refinery they apply to. Now I can run machine learning on that data set and I can create a virtual assistant that's an expert on that oil refinery because it was trained on what people needed to read from PDF documents. This won't be built overnight. It'll take a little while, but I just wanted to give you a little insight into some of the direction we're going in beyond the pure hardware and where you can expect RealWear to innovate in the future. And we'll finish with Boba Fett. We'll hand back to Chris Argos to tell you exactly how you can get your beer. Thank you so much all for coming. We've enjoyed having you, and look forward to lots of conversations.